So our definition of a combustion reaction is something burning in air to produce heat. So generally it's going to be some fuel plus oxygen, okay? Now, if that fuel is a hydrocarbon or a hydrocarbon with an oxygen heteroatom, the only possible products of a hydrocarbon, so C something, H something else, maybe an oxygen in there, plus oxygen, is going to be carbon dioxide and water. So if that is the case, I wouldn't necessarily have to tell you what the products are, because if I just tell you the identity of the hydrocarbon, you should know if it's a combustion reaction. The definition of that is reacting with oxygen. The only possible products are carbon dioxide and water. And then you just balance carbon and then hydrogen and then oxygen. It's always going to be a good strategy because you can always leave the oxygen till last because it's an element by itself. Okay, so let's see what we have. CH3, okay, this fits the brief for a hydrocarbon. Okay, so then our possible products are CO2 and water. Okay, so balance carbon, then balance hydrogen, then balance oxygen would be my strategy. So count up how many carbons you've got. 1, 2, 3, 4, 5, 6 carbons. So I'm going to do that. Balance hydrogen, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So then I guess we should do some bookkeeping. Okay. So at the moment, the number of carbons and hydrogen should be correct. So I've got 6 times 2 oxygens. So 12 oxygens plus 6 is 18 oxygens on this side. Got 1 oxygen over here. So the easiest way to do that is 18 divided by 2, because it's O2 would be 9. Okay. 902. So that should be balanced. Okay. Let's do another one. And if in doubt, if you've balanced something correctly, just remember you can always count up all your elements on each side, make sure they're balanced. So again, it's another hydrocarbon and oxygen. So possible products are carbon dioxide and water. So balance carbon first. There's 2 carbons. So balance hydrogen next. 4 hydrogens over here, so that requires a 2 in front of here. Then how many oxygens have I got? 2 times 2 is 4, plus another 2 is 6, so I can put a 3 in front of that oxygen and I'll be balanced. Okay, I was hoping to find one where we could have some like fractional coefficients. Let's just do one more just to see. We have one that's really horrendous. 1, 2, 3. Okay. So again, carbon dioxide and water, CO2, will be our only possible products. So I've got 3 carbons, 3, 4, 5, 6 hydrogens. So I'm going to put 3 in front of there. How many oxygens do I have? 3 times 2 is 6, plus another 3 is 9. So to balance that, I need 9 over 2 oxygens. So this would be a case where the fractional coefficient is really useful. Okay, if you have an odd number of oxygens, you can't balance that easily with an O2 molecule. So take that odd number of oxygens divided by 2. So to clear that fractional coefficient, I've got to multiply everything by 2. So CH3, CH2 plus 9 O2. Don't forget to multiply everything by 2. So 6 CO2 plus 6 H2O. Okay, so that would be how we would balance that one. Okay, that'll do.